Thanks, Matthew. So within this project, which started this year, so this is the first year of the project, so there's not that many results yet. We are looking at different pruning wound protections to be used in apple nurseries. So the reason for this project comes from a project that I will talk about later in the session, where we looked at the occurrence of canker and wood rot fungi within apple nursery trees. And there we found that certified apple nursery trees are already infected with these pathogens, and quite a high percentage, 65%. When we look at a nursery tree, in terms of where the infection is found, it is found on the sign shoot, also the bud union, the pruning wound on the rootstock, and the rootstock. But the pruning wound on the rootstock and the bud union and the sign were not statistically different. But what we've realized is that the pruning wound on the rootstock is a very important place where infection can take place, and where we can have a management practice that can prevent that infection by applying an effective pruning wound sealant or product. So the objectives of the project is firstly to evaluate the efficacy of selected fungicides in vitro, to test different pruning wound protection products and formulations and fungicides on rootstock plants in 2 nurseries with plants exposed to natural inoculum, and then to repeat that in a situation where we can actually also challenge the protectant with a pathogen. So firstly, the evaluation of fungicides in vitro. So this has not been done for the canker pathogens that occur on apple trees, and the fungicides are listed there. Those are 6 fungicides, of which carbendazim, tebuconazole, flucilazole, and chlorpyrifos. Those have all shown efficacy towards trunk disease pathogens occurring on grapevines, and we're working with similar fungal groups. The imazolone and guazetine are 2 different chemistries that we just want to try to see whether it's effective. And then we're testing it on 4 different pathogens listed there, and we're testing it for its mycelial inhibition and also the inhibition of spore germination. So in that regard, we've got one result of one fungicide, imazolone, that we try to do it for 20 isolates per species. And the values there gives you the EC50 value, the effective concentration by which 50% of the mycelial growth is inhibited. And these concentrations are much lower than the 1,000 parts per million by which this project is the recommended dose. So it might be a possible chemistry to use. So the field trials was initiated also this year. And for the field trials, we're testing the 2 gold standards that are used in the industry, ABE tree seal and ChemSeal, but there's no fungicides in these 2 products. Then also Nucil Plus, there's a fungicide in that product, 8-hydroxyquinoline sulfate, 2 trichoderma products, then carbendazim on its own as bendazid, and then all the other fungicides that I've mentioned previously as commercial products, and a water control. We're doing it on at 2 nurseries over 2 seasons, of which is the first, on 2 rootstock cultivars, oculated with big bugs. So this trial was initiated in the last week of August, so when the plants were pruned back and the applications were made. So on the left-hand side, the pruning wound sealants are applied with a brush, and then the fungicides and the trichoderma are applied with a spray application, a handheld sprayer. Then going on to the artificial inoculation trial, so it will be the same treatments then, just within the context of challenging it with a pathogen, and that we will do after the pruning wound application. We'll challenge with the pathogen 1 day after application and 7 days after application. And that allows us to see how effective the fungicide is, because there is fungicide breakdown that does happen. So the plants were planted, and I'm waiting at the moment. So that's it for this project. I'd just like to acknowledge Hotgrowth Science and the 2 nurseries that are aiding us within this project. So